We are in AP Calculus. Today's date is Thursday, February 27th. We're working on worksheet 10-3. This is the key, the answers. All right, I have a graph, cool graph. We have 3 line segments, and we are saying, hey, g of 1 is the integral from 1 to x. So we're starting here at x is equal to 1, and then going right is positive, going left is negative in terms of the area. So find the absolute minimum value of g on the closed interval between -2 and 4. Okay, so we have our start, we have our change, or start, not change, we have our start and our end, but we need to find critical values. So what does a critical value mean in terms of a graph? You can be thinking about that while we make our table. Sharp corners are where it's not differentiable. That doesn't necessarily mean, oh, that does mean it's a critical value, doesn't it? I guess I should be asking, where are our relative extremas?
1 and
Yeah.
2.
1 is a relative extrema? 1 is not a relative extrema. I don't think 2 is a relative extrema. I think 3 is a relative extrema. Does anyone see why?
Because it's crossing the x-axis.
Yeah, it's where it's a sign change. The height sign change. So let's do this. This is going to be x values. We need to have our start. We need to have -2. We need to have 4. And we also need to have wherever you have a sign change. So let me write up here f relative extrema is where you have, what is the definition? Go. It's where f is f prime, f double prime. Yeah, f prime sign change. And I need to do a better job in my notes of saying these are not really CVs. Yeah, it's an all-encompassing way of getting it, but it's really the relative extremas that you're checking. Okay, so we're talking about the function g. So what is g prime? G prime of x, you guys know how to do this using the second fundamental theorem of calculus. If I take the derivative of g, g prime, take the derivative of the right-hand side, how do I take the derivative of that integral right there? Yep, it cancels out the integral, and then the x goes in there, and then I multiply by the derivative of x, which is 1. So g prime of x is equal to what then?
1.
No, f of x. And f of x on a graph of f of x is what? Height, slope, concavity? Okay, so this is height. So where do we have a, I guess I can change this to a g prime sign change. Where do we have a height sign change? We have that at 3. That is the relative extrema. That's the only one that it crosses. So that's the only one that we need to check in between the start and the end value. So I come down here and say, yes, I also need to check 3. Okay, that's kind of the hard step. And once you get that, you can kind of plug and chug, and it's the same process over and over. But I want to make sure, do we really understand why I'm choosing a height sign change and not a slope sign change? I guess you can only answer yes or no, but if there's a question, now's the time to ask it, I should be saying. All right, well, let's move on. Now I'm going to do my start plus change. And that's going to equal the end. All right, so start. What do I have for my start condition? It looks like nothing. So it's going to be 0, 0, 0, 0. They didn't tell us anything, so we're going to assume it's 0. And our change is going to be the integral from, not from 0, but how do we define our integral?
2 to 2. Wait. 1 to 2.
-2 to 1 is correct, but you skipped a step.
Wait, so the integral is negative?
So it always starts at 1 here, right?
Yeah.
And then I go to -2, but that's backwards. So I'll change this to a minus and -2 to 1.
Wait, but isn't the integral already a negative? Oh, that's an equal sign.
Oh, yeah.
See, I'm blind.
Well, it's not just that you're blind. I really need to retype these notes. Because I should be able to zoom in, and it still looks like an equal sign. I zoom in, and it's like all pixelated. F of t dt. So what is the integral from -2 to 1? I come up here and actually have to do some geometry. So I'm going to make a line right there. Oh, I have a triangle. So -2 to 1. This is 1, 2, 3 by 1, 2, 3, 4. 3 times 4 is 12. Half because it's a triangle, and I get 6. So 0 plus 6 is indeed 6. But negative, yeah, it's a minus sign. Yeah, you can log the extra credit point. You caught it before I did. Okay, this is going to be plus the integral from, again, it starts at 1. It always starts at 1, unless we need to flip it, I guess. 1 to 3 of f of t dt. And from 1 to 3. So I need to find all the area between 1 and 3. Okay, so I see this square shape. I can be a little bit more organized. Can you please stop jiggling the door handle? Thank you. All right, this is an area of 1, and then this is 3 by 1, which is 3, but divided by 2 is 1.5. And we get an area of half for this other triangle, so 0.5. Adding that all together, we get 2 plus 1, 3. 3, yeah?
Yeah.
All right. 3, and then this one is going to be plus integral from 1 to 4 now, so I just have to subtract this additional triangle. Well, these two kind of cancel out. Do you see that graphically? So I really have 1 and 1.5, which is 2.5. So this is going to be f of, come on, computer, f of t dt, yeah, 2.5. 2.5. And what are we searching for again? Absolute minimum. Which one is the smallest? There it is. Nice. So go ahead and type out our answer. Well, you can't type. I'll type out my answer. You have to write out your answer. Absolute min is -6. Where does it happen? At x is equal to -2. I'll put a space there. I always put at where it happens and what the absolute minimum is. Sometimes it asks for one, sometimes it asks for the other, sometimes it asks for both. If you always put both, you'll always get your points. And your justification comes from the fact that you have a table where you're checking your relative extremas. That was number 1. On to number 2. Ooh, we got some semicircles happening here. Yep, it tells us that it's consisting of 2 semicircles. By the way, just making sure the definition of semicircle doesn't mean a part of a circle. It means exactly half of a circle. And 2 line segments, blah, blah, blah. We're finding the absolute maximum. So we're looking for the biggest number over that interval. And this is a graph of f prime now. So it's almost the same type of problem. It's phrased a little bit differently, though. So coming over here. Again, we're trying to find absolute maximum, which means we need to find our start, end, and our relative extremas. The definition of relative extrema, write it down again. You'll have it memorized. Relative extrema is where?
F prime sign change.
There it is, f prime sign change. And on a graph of f prime, what is f prime?
Slope.
On a graph of f prime, what is f prime?
Height.
Yes, f prime is height. Why is my handwriting so messy today? I feel so embarrassed by it. Maybe if I zoom in and then zoom back out, it'll look nice and neat. Yeah, that looks better. All right, so where do I have a height sign change? And that just means where do I cross the x-axis? I cross there, there, and there. So I have 3 things to check, including the start and end value. So my table is going to have 1, 2, 3, 4, 5 different things to check. That's quite a few. Hopefully we have enough room to fit them in.
Wait.
All right. Let's fill in our table x. We have lots of x values to check, but as Arrow said, you can exclude quite a few of them because we're finding the maximum. We have to be careful. We know that we have to start at 1. So excluding your values, you have to go backwards for some of your logic. So if I start at 1, anything going left is opposite, which means this is now positive area and this is now negative area. Does everyone follow that? Because our start is time is equal to 1. That means our integral, whatever, here, let me fill this in a little bit more. Start plus change. Our first integral is going to be the integral from 1 to something because our start time is 1, which means in terms of my graph, I'm starting here. If I go left, I'm going backwards. Everything is now opposite. Below means positive. Above means negative. But now that I'm starting at 1 and going forward, above means positive like before, and below means negative. Everyone is okay with that?
Wait, does that make any sense? Because when the start of the integral is 0, the stuff on the other side of 0 isn't flipped?
That is an interesting question. Do we ever go into the negatives when we started at 0? Because we should have flipped them.
Oh my god. I don't remember if we ever did negatives, but okay. Yeah.
Or this is the only way that you have to do it if you're trying to do the shortcut method. Maybe that's going to mess us up. Should we just assume that everything below is negative, and then we'll flip it in the integral down here later?
Yeah.
Okay.
Well, that's just the link.
You are both very welcome. All right.
It's just
So that means we have to check every single value, though, unfortunately. Here, I'll show you the shortcut method, and then I'll do it the long way.
Yeah.
So going backwards means it's positive, negative, positive, negative. We're looking for a maximum, so the maximum can only occur here, not here, or here. So there's only these 2 points that we have to check. I don't have to check this point because it makes more sense to go forwards or go backwards because I am going to be having some positive area. Yay! All right. So that only saved us one amount of work. We don't have to check that one now, but I'm still going to check as many as I can. We have to check -5. Actually, we don't have to check 5, and we don't have to check -5. Both of those were excluded as well. We only have to check 2 points. We only have to check -3 and 4 by using that shortcut method. So that did save us quite a bit of work. But again, I'm showing you the long way. If you don't know that, just list all of the relative extremas and start and end, and you'll get the answer. So -5, you have to check. You have to check 5, and all the values in between, you have to check -3, you have to check 1, and you have to check 4. Whew, that's a lot of work. Our start condition is 3, 3, 3, 3, and 3. And the integral, we have to be really careful about this, and we don't have very much room. Our integral is going to be from 1 to -5, which means it's going to flip, and it's going to be really minus the integral from -5 to 1. So -5 to 1 is from here to here. We need to find all these areas. Let's go ahead and find them all right now. This is a semicircle. It would have been a circle with radius 1, which means the whole area is pi r squared, or just pi, and this is half of the circle, so pi over 2. This had a radius of 2, so it's going to be 4 pi, but half of that is 2 pi, and -2 pi because below the x-axis. Again, we're not doing the shortcut method, so if it's below, it's negative, and then we'll flip it down here if we need to. This is a triangle. I don't have to check 2 or anything, so I can find the entire area of the triangle. It's 1, 2, 3 by 2. 3 times 2 is 6, but half of that is 3. And then down here, this is -0.5, -0.5. So we have the areas of everything. If I want to find the integral from -5 to 1, that means I'm doing both of these added together, and I get -1.5 pi, essentially. Because this is half, this is -2, 2 and a half. 2 and -1/2 is -1.5, as long as that's negative. I'm saying things wrong, but it's -1.5 pi. Yes. So I have 3 minus 1.5 pi. And you can just round pi to about 3, and you should get roughly the right answer. What about this one? So this is normally going to be 3 plus the integral from 1 to -3, but that's backwards again, and I have to go back and say, no, this is minus the integral from -3 to 1. So what is the area from -3 to 1? Well, that's just -2 pi. So this is going to be 3 minus 2 pi. And clearly, this one is bigger than this one because it's subtracting less. And that's why we didn't have to check. Sorry, we didn't. Wait, what? What's going on? That's positive area. Minus 1.5 pi. This number is bigger. Oh yeah, exactly. So this number is smaller though.
It's 3 plus 1.5.
Oh, that's what it is.
Because it's minus whatever.
Yeah, we forgot to flip it. This should be 3 plus 1.5 pi. Yeah, thank you. Log it. And this one back here, so this should be plus 1.5 pi. I'm sorry, this was, yes. These two add up to negative 1.5 pi, but because I'm doing minus this area, it should be a plus 1.5 pi. Thank you for the catch, Claire. And then this one is negative 2 pi, so minus negative 2 pi is plus 2 pi. Plus 2 pi. Now it makes sense. That's why we can eliminate that one in our shortcut, because this one is bigger. All right, continuing on. This is going to be the integral from 1 to 1, which cancels out, and that's just 3. This is going to be the integral from 1 to 4. 1 to 4 is 3 for that area. So it's 3 plus 3, which is 6, which is bigger, which is why we didn't have to check that one. And now we have to do plus the integral from 1 to 5. Between 1 and 5, now I have to subtract 0.5 from this this 3 right here. So it's 2.5. 2.5 plus our initial 3 is 5.5. 5.5. Which of these is the biggest? Well, it's between this one and this one, just like our shortcut showed us. Can you guys tell which one is bigger?
Is it the negative 3 one? No, it should be that one.
It's this one.
2 times 3.
Yeah, 2 times 3, you round pi to 3, right? 2 times 3 is 6. 6 plus 3 is about 9. So this is a little bit bigger than 9. So this is our answer. And we have to type it out. I don't know if I have the ability to, does anyone know the keyboard shortcut to type in pi? The absolute max is 3 plus 2. Okay, hold on. I need to know this because I'll eventually look this up later. Mac keyboard shortcut pi. Yes, option key, option what though? Option P, really? It's that easy? 2, option P? Oh, that's so nice. Okay, I can remember that pretty easily. And that happens at x is equal to negative 3. Negative 3. Cool. There's our final answer. Whew.
I have a question real quick on the answer key. On the back side, the second one,
Yes.
how did you get the values for all of those?
How to get the values
For the second one.
for this one right here?
When you put the values for all of the areas of those sections, somehow. Like the weird loop-de-loop wave-looking thing is apparently 5.
Oh yeah, we guesstimated.
Okay.
Which one is the biggest?
The loop-de-loop.
Okay, is it positive? It's positive, so take a number out. We can say it's 6. It doesn't matter. Which is the next biggest area? I don't care, negative or positive. Which one is the next biggest? All the way to the left side?
Yeah.
Okay, and then what do you want to call that guy? If that's 6, this must be
I don't know.
estimate. 2, okay. If that's 2, what must this be?
-2?
Yeah, about negative 2. What about this one over here?
Oh, 2.
I would say a little bit less than 2. I'd say like 1.5. Yeah, we just estimated. Yeah, so that was number 2. We're on to number 3. We're looking for the absolute minimum. So we can probably do some... there's only one place that it crosses the x-axis. It's right there. We have a bunch of positive area and then some negative area, and we're looking for minimum. So the minimum can only happen at the beginning or at the end, and it's probably going to be the beginning. Just because we have it's followed by a bunch of positive area, and that positive area is clearly bigger than that tiny little negative area. So this, if I take the integral of the entire thing, it's going to be a net positive, which means this is going to be bigger than this. So the integral between 0 and 8 is going to be bigger than the integral that is between 0 and 0. So how are we going to say that? Most of this answer is just going to be typed. So absolute min at x is equal to 0. Why? Because... I think I'm going to have to write this up because I can't type integrals or anything. I'm going to say because our integral from 0 to 6, this thing right here, its size is bigger than, we'll say, so like the absolute value of that f prime is bigger. Oh, we have to be formal about this, don't we? F prime of x dx. That I don't care about if it's positive or negative. I'm just saying that the size there is bigger than the integral from 6 to 8 f prime of x absolute value dx. I'm only putting absolute values to say, hey, this is a bigger area than that. And hey, that happens to be a negative. I think that's just a good enough explanation. That makes sense to me. If it doesn't make sense to you, I can probably improve it later. But for now, I'm going to leave it like that. That was number 3. Let's do number 4. We already talked about number 4. We just we don't know what these areas are. We just kind of guesstimated. We say, hey, let's assume that's 6. If that's 6, that has to be 2. That's about the same size, but negative. And that's slightly smaller than that area over there, so we called it 1.5. Guesstimating. And then we type in our answer. So we're looking for maximum. So these two cancel each other out, and then a giant area happens, and then another giant area happens. So the maximum probably happens at 7, just because I kind of am back to where I started by this point. So this area and this area, the total accumulation is the same, and then finally we get more, even bigger, and then even bigger because I'm followed by more positive area. So how do we say that? We say that the absolute max is at x is equal to 7. Why? Because I'm going to have to write some integrals and stuff again. So let me come back here. I just want to talk about sizes. So I'm going to say the integral between, I'm going to say that these two are roughly the same, because the integral from -7 to -5 of f prime of x dx is equal to, and that's the size, so those two are equal to each other, between -7.5 and -5 and -1 of f prime of x dx, and absolute value, just those sizes are equal, so they cancel each other out, and you're only having positive values there. So, and I can actually type the rest of this in. And the rest of the areas are positive. I think that's good enough. These aren't like true AP questions, they're like training for the AP questions. Let's try the next one. Ooh, okay, yeah, so this one's going to be a table one again. So we just did number 4, this is number 5. Our final question, we have 5 minutes left of class. I wonder if we can finish this in time. We have our start condition right here. Our start is at 2. And then we have some, this is going to be technically negative, and then that's going to be positive area right there. And then we have negative area there and positive area. I'm kind of doing the shortcut. So we're looking for absolute maximum. That area looks bigger than that area, so we could have a maximum where? And this negative area is bigger than that positive area. The only maximum that I see could be at x equals -3 or at the start. No, it's going to be at -3. I know that the answer is going to be -3 because that area is bigger than that area, and our negative area is bigger than the positive area. So I'm pretty sure the answer is -3. Let's go through the analysis. All right, so we have to check which x coordinates. We have to do the start, we have to do the end. End is 7, and any place where we have a relative extrema, which means it's a height change, because this is g prime, and g prime height change is the definition of relative extrema. So we have to check that point, and that point. So -1, 2, and 6. -2, 1, and 6. Our start is 5, 5, 5, 5, and 5, and then it's going to be plus change. All right, so this is where we have to be careful. This is going to be the integral from 2. It always starts at time is equal to 2. So 2 to -3. Oh, that's backwards, so I have to go back here and say negative integral from -3 to 2 of our g prime of x. G prime. I'm just going to leave it informal. I think it'll be fine. What is the integral, or what is the area between -3 and 2? I have to start dividing all this up. So let's find all these areas. I need that area and all those. Okay, so this is a triangle that's 2 by 4, 8, and half of that is 4. So this is -4. This triangle, this entire triangle right here is 1, 2, 3 by 1, and then half of that is 1.5. This is 1, 2, 3, 4 by 2. That's 8, but half of that, so -4 again. Oh, those two are the same areas. Interesting. And that has a an area of 1/2 or 0.5 because it's 1 by 1 and then half. All right. So now that we know all of that, let's go ahead and fill it in down here. This is going to be between -3 and 2. That's going to be -4 and 1.5. That's that's 2.5. So 5 minus 2.5 is 2.5. Is equal to the end. So we have 2.5. Oh, dang it. I did it again, but no one caught it. I'll let you guys catch it. Who wants to get the extra credit point? It was the same error that I made before. Oh, that's okay. Do you see it, Claire, Arrow, Gio? Anyone? No? Oh, Claire, just call it out. It's fine.
Nope, Sego got it.
Yeah, the area between here and here is -2.5. So this is -2.5, but -2.5. So I should be adding 2.5, and this should be 7.5. I think I'm gonna have to edit this video like crazy to get this to be at the right time. Okay, and this is gonna be plus the integral from 2 to -2. Oh, it's backwards, so I have to come back here and say minus, I'm losing room here, minus -2 to 2, and -2, wait a sec. There's another error somewhere right there, jeez.
There's also an error on Aries.
On Aries too?
Yeah, you put the 10-2 homework is out of 100, so you gave us 5 points out of 100.
I'll fix that.
So
Yeah, I'll log that as well. Yeah, I probably would not have caught that for a while. These are backwards. It should be -1 and 2. So that changes that to a -1.
Just know, I also finished last night's homework.
Okay.
And then I just fixed up.
All right, so this area between -1 and 2 is, yeah, as we said, 1.5, and then I'm going to subtract this 1.5 from, I'm going to do, yeah, so subtract that 1.5 from 5, and I get, math, 3.5. 3.5. And then from there, I'm going to do plus the integral from 2 to 2. Okay, that's nothing. That's 5 plus the integral from 2 to 6 now. So between 2 and 6, that's just -4. 5 minus 4 is 1. And this is going to be plus the integral from 2 to 7. The integral between 2 and 7, so I have to add another 0.5, so it's going to be -3.5. 5 minus 3.5, that is not, or sorry, 5 minus 3.5 is 1.5. I think I have all of those correct. Yeah, okay. And then absolute maximum, which of these is the biggest? That one is biggest. So we type out our answer. We say absolute max is 7.5, and that happens at x is equal to, it was -3, right? Yeah, -3. I can hit enter, so looks better. Yep, there it is. And that concludes worksheet 10-3.